Thank you for joining the June 1st, 2023 The Nutrition Webinar. I'm Marianne Fessenden, Educational and Academic Liaison for AMTS, and your host for this series. Today, we are joined by Dr. William Prokop, Dr. Bill of Dairy Innovations. I will forego my usual intro bio as Bill explains his varied, yet not varied, career in the beginning of his recorded presentation. The original presentation is given twice on the scheduled day with live questions and discussion from participants and co-hosts around the world. After the presentation, you'll be able to listen to the question and answer period for both webinar sessions. I have appended these as well as an acknowledgement of my co-hosts and sponsors after the presentation.
Well, thank you for the intro, Marianne. To the listeners, I'm always apprehensive when people ask for my bio because, as you can see from some of the responsibilities I've had over the years in the profession, it truly looks like I can't hold a job. But just for clarification, I think I owe you an explanation. And since 1993, when I was one of the founding partners of a dairy practice known as AVAPC, I have been part of this and still am, despite the different roles I've had the opportunity to enjoy. And currently, even though I am working with Church and Dwight a good chunk of my time, I am still the leader and director of Dairy Innovations, which is a consultancy group. And I just wanted it understood that that is the role I play throughout my entire professional career, as Dairy Innovations is part of an umbrella that tries to serve the dairy industry by constantly improving and innovating new ideas. So I want to also have it understood, I'm not a researcher. I attempt to teach it and apply it, and I collaborate with researchers that'll tolerate me. But I claim no expertise, just enthusiasm. And I also want to mention the researchers who provided a lot of the information that I'm going to share. In Italy, Trevisi, Minuti, Bertoni at Catholic University. In the US, Lance Baumgart and his group. They, I believe, have provided some of the most recent pivotal information about our understanding of the inflammatory response in cattle, which we'll discuss later on in our discussion of heat stress. So this topic is entitled Real-Time Practical Nutritional and Non-Nutritional Considerations for Mitigating Heat Stress in Dairy Cattle. And what I want to talk about here are real-life experiences that myself and Jeff Kiernan, a colleague in Church and Dwight, have experienced. And I want to share what we've learned and what we know, and provide perhaps a resource for those that are embarking upon implementing strategies. And so Jeff has put together a very eloquent packet of references, and he has a lot of qualitative and quantitative information as to the specifics of, for instance, the plumbing and the electronics needed to affect effective cow cooling. And he works in California where the temperature often hits 100 degrees. So he is quite familiar with heat stress in cattle and the need to mitigate that. I am not going to dwell on the quantitative aspects in his information. I will mention the important ones, but otherwise they're there for reference, specifically the manufacturers and suppliers. We're not doing this to endorse, we're doing this to supply information with what has worked well in our hands. And I will be doing the same thing. If I reference products, it is not that I am saying that that is the only product out there, but I'm telling you that this one has worked in my hands. So, again, I'm sure Tom in his last talk, which I didn't hear anyway, brought this up, but just a review of the THI. The importance is this is the threshold above which the heat takes its toll and obviously causes a loss in productive life of the cow. And the current THI is 68, and that's based upon obviously temperature and humidity. It does not take into account convection currents of wind or radiation of the sun. And so it's a simple and effective term, but probably the black globe technology, which takes into effect solar radiation and air currents, is probably a better one to use, though more complex. And given this, while 68 is the THI above which we have a problem, I think the warning track starts at 65, and that's when we start paying attention to the fact that if we're not implementing strategies to mitigate heat stress, we better do so soon before it's too late. And again, this chart, which compares the human THI to cattle THI, the important part here is the cow is much more sensitive to the heat than we are, and we feel it at about 80 degrees Fahrenheit, 40% relative humidity. If we wait for a cow to hit that point, she's already in a moderate heat stress condition, and that means her respiratory rate is above 75, and she's probably lost the equivalent of about 6 pounds of milk. Rectal temperature has gone up. And so I think charts like this are handy for the purpose of client education to reinforce the importance of the different thresholds and what the parameters are by which we can quantify whether cows are in heat stress, and if they are, to what degree. So here's a comparison of heat mitigation using a combination of either water and fans or neither. And the first line, the red line, shows that we have no treatments taking place there. If we add fans, and just fans, to that, we see we get a slight reduction over time of the respiratory rate as a surrogate for the heat stress. Again, that's over 90 breaths per minute. The next is soaking it for 1 minute, 0.35 gallons for every 15 minutes. And you can see that that drops the temperature down, the respiratory rate down below 90, but still it's fairly elevated. And we continue down the list here, we see that if we do that 15-minute interval soaking and apply fans, we get a further reduction, in respiratory rate, so more cooling. And it's not until we get down to an interval of soaking every 5 with fans do we see the greatest reduction. However, if we look up the chart to the green line, which is soaking every 5 without the fans, we achieve about 80% of the effect with fans. And so the point of this is we can't always soak as often as we want, and we can't always have as many fans as we want owing to availability of electricity. And the soaking is a big function of water availability and how we dispose of that water. Because as a dairy manager, I can tell you, filling the lagoons every summer with cow cooling water is an issue, and we've got to get rid of it. So this gives us an idea of the impact we can have when we can't have the most optimum of situations. And just to review, we know that the cow cools by conduction, convection, and radiation of heat, and those are all based upon gradient. It means she's in contact with solid or fluid surfaces that are cooler than she is, and so the heat moves away from her into those couplings around her. And then we have evaporation, which initially takes place in her lungs, and again, that's an active process that requires the movement of air across a moist surface, taking the heat away from her to activate the molecules in the water and cause them to evaporate. So When we look at the impact of those different methods of cooling, as her temperature increases, she becomes more dependent upon evaporation from the skin surface. If we look, respiratory evaporation can account for maybe 25%, okay, of heat dissipation under the most extreme conditions. And at the same time, heat dissipation from conduction, radiation, and convection is only about 10 or 15% at those extremes. So that's where evaporation from the skin can be a very critical part of cooling under these extremes, and why it is critical to consider that type of technology to mitigate the heat stress. So the point, I think, of Jeff's slides, which I'm going to start now, are if you're going to spend money on cow cooling, get it right. There are a lot of ways of spending money for cooling and have a very ineffective outcome. And what Jeff is going to share in these slides that he's generously let me borrow are the systems that are working on real-time dairies in California. So it starts off with this little spray nozzle. It's called a TFVP 7.5. That doesn't matter as much as the fact that this is what delivers the water to the cow across her back, and this is the dispensing unit that we're going to be looking at to make sure that we get effective coverage on the cow. This green tip nozzle requires a certain flow rate, and if that flow rate is not available, Jeff has alternatives that can be used under different conditions of pressure and flow rate, and I'll show you those. So again, this is the dairy soaker nozzle that he references, and there's a supplier for those interested. Again, we have no stake in this product. It's just so you know what equipment works. Okay, so let's take a look at a good installation of soakers. As you see these cows standing there, you can see that they're wet across their entire surface of their backs, okay, by how shiny it is. And the more area that we soak, the greater the evaporative skin, greater evaporation there is and loss of heat from the skin. And so this is very good coverage for a system. We want to spray the cow and get her soaked, and we want to do it in about 20 to 30 seconds. And in order for this to happen, we have to have check valves in the line so the line never depressurizes. It always maintains water. And 20 to 30 seconds should be all it takes to get the cow soaked. The other thing here to notice in this picture is that the water is not overshooting the cows. It is not going beyond their tails onto the ground. We want this to be effective. We also want large droplets of water because that's more effective for soaking. And that's what we're achieving here, and that's what we get with the nozzles that Jeff has indicated. Okay, so we want the cow to evaporate 80% of the water that's soaked on there before we start re-soaking her again. That is the optimum for getting the most amount of cooling for the application of the water. So here's a good photo of showing you the large droplets in an effective system and the way it arcs across what would be the cow's back. So you can see in these white cows where the water is soaked through, you can see the pink hide. This is terrific coverage, minimal coverage on the udder because we're not trying to wet the udder. We know the risks associated with that and mastitis. And again, we should be able to effect this type of soaking in about 20 seconds with an effective delivery system. Now, here's a less than optimum situation. These girls are getting soaked adequately in the front half, but about 40% of the surface is not getting covered, soaked with water. And that's because the angle of these spray nozzles is set too far down and need to be brought up to reach across their back. So again, it's not that they're not getting cooled, they're just not getting cooled as effectively and more water is probably going on the ground as a result, which is doing nothing for evaporative cooling. This is an interesting comparison. If you notice, the soakers that I'm pointing out with the cursor here are only hitting the front end of the cows. At this point, they raised these soakers to reach further across the backs of the cows, and you can see here they're getting full soaking. So this is a system that was undergoing adjustment, okay? So they changed the nozzle angle in order to get full coverage. And for those techies, these nozzles are faced about 5 feet apart, and this is on a 3-inch line with those green tip nozzles delivering the spray. Okay, so here's an example again of effective coverage and allowing evaporation to take place before resoaking. Here's the jerseys that are getting soaked up front, but not past the lumbar region, so we're missing out on an opportunity. And here's one where, again, those of you who have experienced this know that one of the risks of soaking is to get the feed wet when you get cross breezes and drift of water, and then you get secondary fermentation and spoilage. So this dairy tried to have a excess inset of the line. They moved it off the neck rail, or the headlock rail, and further back, but by doing so, they basically missed the front end of the cow, and they actually pushed more water past the end of the cow. They overshot. So understood the concept, just that it needs some refinement. Like this needs to be brought up closer here. Okay. Given the fact that water is precious in most areas, and we don't want to have any more manure water to deal with than we have to, there are different technologies available now that provide sensors so that the soakers only go on when there are cows there to receive it. And so in this picture, this holding area, you can see that all of these spray nozzles are working. And as the cows in the holding area move forward, they shut off the ones further back, and just the ones where the cows are on. And so there are different sensors that are available, whether it's for individual cows or more commonly for quadrants, an area sensor. And again, these technologies are out there for those where water use is restricted or just not available. So here's an interesting picture. This is a 2-inch line, so it's an undersized line because if it runs more than 500 feet, 150 meters, it can't hold up for the amount of spray that we want. And you can see between the nozzles there are voids here. Okay, so cows would be missing out on coverage. So this line is undersized for the run. It can't hold up the pressure for that distance at that 2-inch size, 5 centimeters. The other thing that this is depicting is side-mounted fans, which we now install over the beds, but also to get an angulation onto the cows to get evaporation while they're standing at the headlock. The other thing to notice here is the beds stay dry. We're not doing anything to soak the beds. We're keeping the water in the alley where the cows are and hopefully on their backs. But we definitely need to fix this, either the size of the line, to get more coverage with the current spray nozzles that are on there. The other thing too about fans, and this gets technical and you can read this all you like, but there's 2 considerations when we're picking out fans, and that is the throw, how far it will project the airflow, and how wide that flow will be at that point, because we do want a minimum amount of airflow, and otherwise we're not going to get the effective evaporation. And again, we're only going to get cooling if we move enough air to get the evaporation. And so sizing the fan is critical, and not all fans with the same specifications perform equally. And so an unbiased source of information on this is Best Labs, which is run by the University of Illinois, where they do a comparison of different fans to tell you how effective they were. And the ones in these pictures were Aerotex 51-inch panel fans. And again, just saying this is what's worked for them over the years. I'm sure there are other good ones out there. I'm just sharing what we know. These are the controller valves, and this is what turns the soakers on and off. And again, you want to have these set so that you get your soaking done in 30 seconds, and the off time is the amount of time it takes to get 80% of the water evaporated from their skin, which will be a function of how much air you're moving over them. Okay, so evaporation duration decreases as the air velocity increases. That only makes sense. And so we adjust the on-off accordingly. And again, these are examples of other pieces of equipment that can be used to affect this heat mitigation. But bottom line is, the more wet dry cycles per hour, the more heat transfer we're getting away from the cow, the better job we're doing at cooling her. Looking at the holding area or wash pen, it's critical that we know that the cows are walking into the airflow, and the airflow is going away from the parlor. It doesn't matter which way your prevailing winds are. You want hot, humid air from the holding area going away from the parlor. And this is depicting where the fans are positioned, and the circles are the cones of the coverage of the spray nozzles from the water spraying down on the cows in the holding area. And again, with the holding area, as with the headlock sprayers, we're trying to get large droplets so that we don't get a lot of drift. We want uniform coverage as if they're in a rainstorm. We have check valves to keep the lines full so there's no on-off time. It starts immediately and stops immediately. And again, we need timers so that we turn off the water as soon as the cows are soaked. But high velocity airflow is critical, because without that, all we've done is create a lot of humidity with the soakers, and we're not going to get the advantages without the airflow. And as always, we don't want the cows standing in the holding area any longer than we have to. And again, examples of the nozzles used for the holding area, they're different than the ones on the headlocks, because these valves have spinners inside to get that cone of dispersion, and so it's a slightly different application and requires slightly different equipment, and it's all spelled out there for those of you interested. The other part of this worth considering is we have to understand the spray pattern height, the height of the cow, how wide an area that of coverage we're going to get, so that we get overlapping of cows from one nozzle. And all of these things depend upon, the installation and the specifics of the holding area. But typical mount height is in the U.S. 9 feet, so 3 meters metric, and in a 7-foot grid pattern, so 2-meter grid pattern. And again, these are other valves that are used in the holding areas to affect good coverage. And that's what it looks like. It's a perfect rainstorm. You have 360-degree nozzles with overlapping supplies of droplets, and you have a uniform wetting of the entire holding area. And that's what it would look like with the cows. And so here you can see there's banks of fans blowing towards the cows as they go towards the parlor, and we have 4 lines of soakers there in this application for very effective cow cooling. And this is a rotary parlor, and again, just emphasizing the fact that we have banks of these 51-inch, 130-centimeter fans and a grid soaker system that they walk into. And again, that can be zone controlled so that it can come on just where the cows are standing. Now, here's a situation where they put in lots of fans but no water. And sorry about that. When you have this type of setup, moving the air is going to give you convection cooling, but you don't get any evaporation. And while convection with cool air can be beneficial, with the ambient warm air, it's better than nothing. But compared to evaporation, evaporation is 22.6 times more effective at cooling cows. The other thing to look at too is radiant heat that comes down either through clear panels or infrared that comes through the panels that absorb heat of the sun and allow it to transfer down to the cows. Okay, those are highly effective sources of heat stress to the cattle. This is called an IWAB, and it basically is a device that articulates so that when it sprays, it sprays out in a very large circle, about 206 square meters or 2,500 square feet, compared to a conventional nozzle, which is only going to give you a diameter of, or a square footage of about 513 square feet, 48 square meters. So this device, in theory, sounds like a good idea because you need fewer of these devices to affect the area that you're trying to cool. However, the problem with the IWAB is it's not a uniform pattern, and some cows get soaked more than others, and there's also excessive wetting of the udders as a result of that. So they can be made to work, but there are some qualifications here, constraints that you have to observe to make sure you get the effects that you want. But you can see here in this picture, the cows are certainly getting soaked. Return lane soakers, I think, are a tremendous asset for heat mitigation, whether they're homemade or commercial units. The important part is we have a top-down application, and if possible, the spray should come on when her head is past the first spray jet, because cows don't like getting sprayed in the head. Obviously, that all animals are going to back away from that. So if it starts by electric eye or whatever the device is that senses the presence, that will work very effectively. And the one on the left is a homemade system, and the one on the right is a commercial Edstrom CowSense motion cooling system. Now, these are single cow lanes, and those are most effective because the cow behind pushes the cow ahead. If we do a wide lane soaker, as you see down here in the center, you can get a traffic jam because cows are not forced through necessarily by cows behind them, and so hesitation to move through can cause the cows to build up on one side. So in summary, for evaporative cooling, okay, we want to soak the surface as quickly as possible, large water droplets, get it done in 20 to 30 seconds. We want to make sure the surface area of exposure is covered completely, meaning the top. And so, because more skin that's wet each cycle, the better cooling we're going to affect. We want increased airflow, whether that's natural or mechanical, to affect the evaporation. And obviously, the lower the humidity, the better off we are. Can't always control that. But the point being, if you maximize the number of wet-dry cycles per hour, you're going to mitigate the greatest amount of heat stress. We use check valves to keep the lines full. Having adequate line pressure is critical. And at the same time, we have to know that the line is large enough to handle the distance it's going to go. Because if it's too small, we will get drop off and we won't get effective coverage. So typically the spray nozzles in a good system are every 2.5 to 3 meters, and that would be on a 3-inch line, so a 7.5 centimeter line. We want to make sure the angle of the nozzle's position will get most coverage without overshooting the cow or getting the beds wet. And we want to make sure our controllers are adjusted based upon the current conditions to give an optimum amount of soaking cycles. It's not a set once and forget about it. It's something that requires attention, periodically as the ambient conditions change. Because remember, what we're trying to do is affect a microclimate around this cow. Not the ambient. We're not changing that. We're changing what she experiences, not what's around her. On the subject of water, we all know that a cow is going to drink 30 to 50 gallons, 114 to 119 liters a day, in roughly 4 to 4.5 pounds of water per pound of milk. So one of the cheapest things we can do is provide more clean water to any dairy situation. It's kind of like dry matters on forages. I've yet to find dairies that can't do a better job of improving cow performance by doing dry matters more frequently. And the same thing was with water. When we add more water supply for the cows, we get a milk response. It doesn't seem like we've maxed out the amount of water that they need or they would like. Because again, she'll drink if it's convenient. She might not get up to go get a drink as often as we would like if she's lying in a stall. So the access per cow is about 7.5 to 10 centimeters. That's 3 to 4 inches per cow of linear space. We've got to make sure the floats are adjusted to keep the troughs full, to utilize the full capacity. If you're chlorinating, then again, be aware of the fact that some cows are sensitive to chlorine and that could cause them to back off. I have not seen any one number of concentration of chlorine. I've seen situations where cows will drink more chlorine than people would recommend, and other situations where the slightest bit of chlorine and the cows back away. So don't have an answer for you on that one. Cement troughs are good, but they're a little more of a challenge to keep them fresh because the surface gets rough and pitted. So as long as they're kept clean and possibly chlorinated, if you can make that work, that's fine. If it's a V trough, as many of them are, then the volume is compromised, and so you want to make sure that you maximize the fill and that the float is set so that it keeps it full, because once they start drinking it down, the water supply drops off very quickly. So these are the simple adaptations that we've seen that have made the biggest improvement. Is return lane water. We supply 2 linear feet per cow returning from the parlor. This is just PVC that's been cut, and it's a very simple and easy option to install. So this is a double 30 parlor. So for those 30 cows coming out, we need 60 feet or 118 meters of linear water space to allow all cows to drink. And again, no surprise, they're very thirsty physiologically speaking after being milked. So having this available to them improves dry matter intake by consumption of water. And don't forget, unless the water is especially warm, which it is not likely to be, you're getting internal cooling by conduction as the cool water comes in and pulls heat from surrounding tissues that are warm. The other advantage to this as well is obviously to keep cows standing longer after milking so that the sphincters have a chance to reseal before they go and lie down. The same concept about why we want them to eat after they've been milked. So this is a great way to encourage them to eat by having the water on hand, and they proceed back to their pen and stand at the headlock to eat before going to lie down. Here's a 15-year-old installation just to demonstrate that it stood the test of time. And again, a very simple, cost-effective approach. And you can see how clean the water is there. So this is a setup where they put the water trough, additional troughs, both on the entry and the exit. On the entry side, it doesn't really cause a traffic jam because the cows are usually not that thirsty on the way in, but it doesn't hurt to have it for those that want to stop and take a drink. The exit side is where you're going to get the majority of your takers, okay? And it's critical that we have these set up at the proper height to accommodate them for easily drinking without getting any contamination from surrounding splatter of manure and such. Now here is a large diameter PVC pipe, but you notice they've relieved all the surface, and if you don't leave some reinforcement ribs across the top, you're more likely to have problems with breakage. Okay, so regarding cow cooling, some of the watchouts. Make sure the water lines are not undersized, because these variable flow nozzles will result in inadequate pressure flare-outs, and you won't get good coverage. Nozzle spacing that's too far apart is also an issue. So, again, 1.5 meters typical nozzle spacing, 5 feet on a 3-inch line provides good overlap of coverage. Water that's on too long, once the cow is slick, obviously it's just a waste of water. You're not getting any more benefit to justify the use of the water. Fans for airflow with no water don't tend to be as effective as those that are used for evaporative cooling. So the use of fans for evaporation are critical. Must have fans together with water in the holding area, especially with the stocking densities that we have, or will create too much humidity from the water alone. Holding areas, we want to make sure we're moving the air away from the parlor. Some dairies install the soaker lines off of water trough lines for convenience. The problem with that is it'll rob the troughs of water, and the recycle time on the troughs will go up, and so the cows won't get the water they want to drink. And in the center picture down here, if my mouse will work, here we are, you notice that there's a lot of elbows in this connection, and every elbow that's added to connect one line to another, especially if it drops from 2 inches to 1 inch back to 2 inch. When we put elbows like that in, we're effectively adding about 100 foot of distance in terms of pressure loss. And so that's something we want to avoid, elbows at all cost. Obvious mistake here. These cows have full sun exposure until they get under roof here, so they're just baking these cows. This picture in the lower right shows fans blowing in 2 different directions in a holding area, and that is not effective. Obviously, we want it blowing away from the parlor towards the cows walking in. Okay, so keeping cows cool in California, heat abatement. They use shade, they soak, and they move air. Very simple, okay? And maximize wet-dry cycles per hour. In terms of water, I can't say enough about it, not just from the thirst side, but also from the perspective of internal cooling when they drink that cooler water. Now, if your water is 70, 80 degrees, then obviously you're not going to get the benefits you will if you get water coming out of the ground at 40 or 50 degrees, and that depends upon your location. We want to minimize heat gain and maximize heat loss. And Jeff has a disclaimer there. This works for him, but check with your local professional before implementing other systems. And his contact information there, and he welcomes any people with questions. Again, Jeff's been doing this. Jeff and I have known each other now for over 20 years, and in his sphere of influence, he does a tremendous job of helping his clients affect good cow comfort by mitigating heat stress with effective cow cooling. Now, what I want to talk about is heat stress and its effects on the cow through leaky gut and subsequent inflammation. Now, I'm just going to hit on some current research to challenge the way we think about certain things, and I believe there'll be speakers coming forward that I reference in the credits of the researchers that will give you a lot more specifics, but from a practical side, something I want to share. So let's start with this gentleman. All disease begins in the gut. Hippocrates said that 300 BC. He considered the gut to be the root cause of a lot of diseases. I think that's a fascinating observation. If you consider the exposure of the animal to the environment, the cow's skin, external surface, is about 7 square meters. Her internal surface exposed to the environment, her gut, is almost 2,800 square meters. So just consider, okay, the challenge risks presented to both of those areas. So heat stress, leaky gut, and inflammation. We see a loss of dry matter intake and productivity as a result of this cascade. And what happens is with heat stress, we get blood diverted from the gut in order to radiate more heat to the skin. Well, the enterocytes lining the gut experience ATP depletion and oxidative stress as a result of this intestinal hypoxia. As a result of this, the junction between the cells, the tight junctions, suffer disruption, and we lose the integrity of the intestinal barrier. And this allows leakage of intraluminal gram-negative bacteria, the LPS, lipopolysaccharide bugs, into circulation. Now, the body responds by sending lipopolysaccharide binding protein to grab the LPS and deliver it to the immune system to activate it through CD14 clusters of differentiation 14 and toll-like receptors 4, and we get immune activation and inflammation. And so we know this because we see acute phase proteins, the LBP, serum amyloid A, haptoglobin, and these things start to spike in the blood in the face of heat stress, secondary to the leaky gut. The thing about these acute phase proteins is that they're very potent anorectic factors, and they result in dry matter intake loss. Okay? So, in addition to this, as the immune system becomes activated to meet the challenge of the pathogens that are introduced through the leaky gut, white blood cells become activated and they become obligate glucose consumers through aerobic glycolysis. She goes into a metabolically inflexible state, and the peripheral tissues become insulin insensitive. We have less glucose going to the mammary gland. That means there's less lactose, and that means there's less milk. So the cascade of heat stress resulting in leaky gut, resulting in inflammation, that results in loss of productivity, okay, I think is something that we have to recognize. And yes, we're trying to mitigate this by controlling the microenvironment, but I think we have to consider what's going on the inside through all this as well. So here's a depiction of this. The LPS bacteria are able to penetrate through the enterocytes or between the enterocytes, go into the portal circulation. Okay, they're picked up by LPP, which is great. And that delivers them to the immune system, and we mount an inflammatory response with those acute phase proteins, which, as I said, end up causing dry matter intake to drop. So there are a lot of stress factors proven to promote leaky gut. We're talking about heat stress because it's that time of year, but overcrowding, excessive pen moves, dietary changes, imbalances, SARA or rumen acidosis, full-blown rumen acidosis, all are incriminated in leaky gut. So is limit feeding that leads to slug feeding, and even poor pen hygiene, where we increase the bacterial challenge not only to the gut, but to the udder and to the reproductive tract. And so this emphasizes the importance of us reducing stress in order to improve and optimize animal well-being. Now, the comment is they didn't show any signs of stress, they didn't show any signs of illness. And that's true, because in most cases, the inflammation that's taking place is subclinical. And as shown here by Trevisi and Minuti, they did some work on normal transition cows, and they observed these spikes in inflammation, inflammatory markers, even though these cows did not present with any clinical disease. The point is, as other entities that the cow deals with, subclinical is our biggest challenge because we don't see it. She plays poker too well and she bluffs us into thinking she's fine. But we know they're there based upon the blood markers, okay, that are going up. So we know the gut is compromised by stress factors, and the bacteria penetrate, and it triggers the immune system activation, and we get inflammation, okay? And we have evidence of that by these markers that I just pointed out, haptoglobin, SAA, and lipopolysaccharide binding proteins. Okay. What's interesting is the decrease in milk production is not completely accounted for by the decrease in dry matter intake. And so if we look at an inflammatory response, and I'll go through this. Once LPS gets into the system, we know that glucose is going to be diverted away from the mammary gland, and that's because the white blood cells require it, okay, as an obligate source glucose user. And we get reduced dry matter intake. We're going to get all sorts of unhealthy fat mobilization, okay, as she tries to mobilize fat to provide the energy needed for other tissues from which the glucose has been taken. And we also know that there's a negative impact on developing follicle fertility for subsequent breedings, future breedings. So all this cascade is taking place as a result of inflammatory activation. And so you ask the question, the host is challenged by a potential pathogen via some opportunistic stress. Yeah. Immune system is activated and inflammatory response ensues. Okay, so what's the big deal? That's what our immune system is for. Well, when we have this immune system activation, there's an energy cost. We know milk volume is driven by glucose to lactose. Activated immune cells, as we said, require glucose. And one study done in Lance's lab, Iowa State, where they used a euglycemic clamp, they demonstrated that a full-blown crisis, inflammatory crisis with immune activation costs a kilogram of sugar every 12 hours of glucose, okay? And as I said earlier, glucose is no longer partitioned to the mammary gland because it's being used by the immune system, all right, and production suffers. So 1,000 grams of sugar every 12 hours. So consider that 72 grams of that sugar is required for a kilogram of milk. Therefore, out of that 1,000, we're going to lose about 14 plus kilograms of milk loss in that 12 hours. Now, that probably is a clinical response. In other words, a coliform mastitis, I believe, is what they emulated to produce that glucose deficit. But it would be the equivalent of a normal LPS challenge. But what about all these subclinical inflammatory responses that are not clinical, but still have inflammatory responses and activation of the immune system at some level? We're still using glucose diverted from other productive tissues to affect this response. And so, if it was 20% of a full response, it would still be 200 grams of glucose, and that could be 3 kilograms of milk loss. And so those cows that Traversi and Minuti showed you with all those inflammatory spikes didn't show illness, but they were still consuming glucose, diverting glucose away, say, from feeding that fetus, which we know that the fetus requires glucose or amino acids after 190 days gestation for the growth exponential growth that it's undergoing. So we have to consider the costs at all metabolic levels of these insults, starting with heat stress. Oh, there again there are these inflammatory responses. So, just because we don't realize they're there doesn't mean it isn't happening. And again, just to reinforce, these immune activation mediators, the inflammatory mediators, cause reduction in dry matter intake, and that's been proven across numerous studies, and the references are there. Okay, so what if we could help mitigate heat stress from the inside out? If we had a technology that could reduce leaky gut by reducing host susceptibility through improved gut health, or maybe by reducing the pathogen challenge in the gut, and thereby reduce the subclinical immune activation and inflammation. The technology is called refined functional carbohydrates, which basically is yeast cell wall split up into its active ingredients. The mannose that supports the growth of bacteria like lactobacillus and bifidobacterium, the moss that serves to bind bacteria like E. coli and salmonella, the beta-glucans that can support the immune system and help maintain the integrity of the tight junction, reduces cytotoxic damage, and the other effects that they can have on reducing protozoal impact from crypto and amelia. So these RFCs are proven, okay, by enzymatic fraction of the yeast cell wall into the active ingredients. And here's an actual representation of what this looks like, just to show you, because I wasn't a believer until I saw this. That is an RFC liquid known as Celmanax being added to a plate of E. coli. And as I said earlier, the moss serve to help agglutinate and bind the bacteria so they cannot preferentially bind to the gut. And as we see, after a few seconds of this being stirred around, the agglutination of the E. coli starts to take place. And that's one of the effects, the beneficial effects, because that reduces the challenge in the face of a leaky gut. This is even more interesting. Two groups of cattle, same diet, same environment. They were subjected to heat stress, and the THI in that heat stress was 60 to 90 based upon the respiratory rate to keep the respiratory rate at a safe level, okay, so that these animals weren't going into the red zone. But what's fascinating here, if I can get the video to play, the cows on the left had the controlled diet. The cows on the right had the same diet, except it had the RFC technology in there. And I think you can see pretty obviously which cows don't appear to be demonstrating any respiratory distress and which ones are having trouble cooling and hence panting. And also interesting to note that the cows on the right seem to be grazing on, thinking about eating, which is the last thing the cows on the left are doing. The panting behavior was reduced in 3 out of the 4 trials, and in the latter trial, H, there was no difference in the panting. So understand that the respiratory rate of these cows was comparable, okay? It's just that the cows that were heat stressed needed to do that to blow off a lot of excess heat because of the stresses that they were undergoing, whereas the other cows, where the gut was protected, were not going through as much of an inflammatory response. And they were slaughtered. This was a slaughter study, so we can look at the tissues, but just for the record, the control cows had swollen, thickened hepatocytes. There was damage to the lungs, the heart muscle, but the interesting thing is to look at the rumen papilla, the gut. So here is a control cow and the architecture of the rumen papilla. As you can see the description there, but basically the cells are pycnotic, meaning we're undergoing death here, and the architecture is very disrupted. Now here is a treated cow, and you can see that this architecture is much more intact. This is the rumen papilla. It's healthy. There's nothing wrong with this. Again, this is a healthy cow with the papilla. You can see that normal tissue section, and the cells are in columns. The architecture is preserved. Compare it to a control cow, where the duodenum shows necrotic exfoliation of the mucosa, and again, we have a lot of tissue destruction here, and tight junctions would be compromised. So, in consideration of all the stressors common to dairies, can we eliminate stress? Well, good management, housing, good husbandry practices will mitigate or reduce the effects of stress, but recognize there's always going to be some stresses, perhaps beneficial, such as those during parturition, but transportation, environmental stresses, certainly we can mitigate, okay, through better management practices. We will never eliminate all of them. And again, our goal here is to have an effective microclimate management for heat stress abatement of the cow. As this example shows, advanced feed technologies can be used to protect the entire gut and prevent pathogen load, protect the intestinal cells and damage by pathogens and mycotoxins, and actually help the immune system be aware of the need for activation. Because what we're trying to achieve is an edification of the gut to make it more resilient to the challenges, okay, so that it doesn't experience any more inflammatory response and the metabolic consequences that is necessary. And I think mitigating heat stress from the inside is an opportunity that we all have to consider with the technologies that are available. And with that, I will say thank you for listening, and I will turn this over to Marianne.
That completes the presentation part of the webinar. Firstly, thank you for joining us. As a reminder, today's slides will be available as a PDF document for download from our website. The page with the link to the PDF will also have a link to the recording on YouTube. You can find the correct page by looking under Webinars 2023, The Nutritionist. Click on the button under the appropriate webinar listing. I do convert the audio to podcasts. You can find those under the podcast tab on our website or subscribe on Apple Podcasts and Spotify. Next month's webinar will cover in more detail the effects of heat stress on production with a presentation from Dr. Lance Baumgard on the pathophysiology of heat stress and the consequences to productivity. Now follows the question and answer sessions from each presentation. For the convenience of the global audience that joins us for the webinars, we offer the recorded webinars twice on webinar day and record the question and answer session for each. For this reason, you may observe repetition in the questions. Additionally, we take the recording once posted and convert it into a podcast so that you can listen to them as you're driving. My other co-hosts, please unmute yourselves and say good morning. I'm waiting for some questions. I'm getting a little bit of echo back at me, but I don't know why. Elena, hello.
Hi, Marianne. Probably the echo is mine. I'm driving.
That's okay. That's okay. It's good to have you join us. Before we get rolling, I am going to, Salvador has a 5-slide presentation. I'm going to let you do that so he can explain a little bit about what he did. We did have some discussion in our last webinar of the work that Salvador and Marty have done together. I need to make sure that Salvador can share his screen. So give me a moment to check my settings. It looks like, Salvador, I just will stop my share and you can go ahead and share your presentation if you're ready. If you'd unmute and let me know.
Yes, let me try to do it quickly.
Okay, I'm going to stop my share.
Okay, and okay. So
this is a little bonus for our attendees today.
Please tell me if you can see my screen.
Perfect. Yes, I can.
Okay. Hello, good morning to everyone. I am Salvatore Rivas. I am from the North Center of Mexico, and I am the founder and CEO of Digit Technologies. Digit is a technology company that works with the idea to develop innovate technologies that allows the team of the farms are also the nutritionists, all the people that get involved with the farmers to take data in a huge accuracy and take the better decisions so you can fight the heat stress in the right way. So we developed technology, an application a few years ago. Maybe a few of you maybe have seen and a few of you don't. But for those who knows the application, what this app does is that connects to a weather stations system that provide us precision data from temperature and humidity, and we can calculate the in almost everywhere in the world. Is very accurate, the technology. And we use the algorithm that makes the THI number for the last equation, and that they start at 72 or 74 the Fahrenheit, that is more like 68 THI index. Okay. Let me tell you what I see about the heat stress. Okay, in Mexico, we believe that the heat stress is like racing the F1 competition. Okay, and the heat stress is the Ferrari team, and they want to beat you, and you need to fight them. And usually, you are blind in your eyes because you don't know what is the heat stress that is coming in the follow days. So the THI application, what it does is that gives you the accurate data in the follow 2 days, 4 days, or 7 days in forecast, with a 98% of precision data with the network that we are connected. And with this data, we can face the heat stress in another way, because we know what is going to happen in the follow 7 days. I don't know if I am telling you properly, but what is going to happen is that you can see what is going to be the temperature of the following 7 days, what is going to be the ambient temperature, the heat stress, the wind speed or the duration of the wind, sunsense time, the daily daylight, and all this data that maybe you will need, and your nutritionist and all the team in the farm, and face the heat stress in the proper way with this data. The application is available in the App Store, on the Google Store. Just a couple of things. Since March, Apple buy the network that we connect to. We are now moving to another provider of these weather data systems in the applications. But Martin, Dr. Traxler, is using our heat stress reporter. It's the same technology, but what it does is that provide him the accuracy of the THI, as you can see now in your screen. This is the data of how the graphs are generated. And he has accurate data of the heat stress of the follow 7 days. So, and it's accuracy through GPS locations is and they call it is geolocalization high accuracy data is the way these companies of weather forecast sell the data. And with this technology and this data, Dr. Martin is available, and his team of Lattice is available to give proper decisions and take the right way to go in making adjustments on diets and everything that he does with this data. You don't need any electronics to add this technology. You can only send us the GPS location of what is the farm that you needed, and in less than 15 minutes you have all the forecasts daily if you need it, or maybe once a week as you will need it. And with this, you can take decisions of how to face the heat stress. The other interesting thing is that you can take all this data and put it in a year graph, so it can give you how was the heat stress of that particular farm. And you can make a footprint, if you want to say that here, or a thumbprint, that you now know what is the usual monthly heat stress that you will have in each of your dailies. And this is powerful data, because now you know what is the stress that you need to fight to each of your customers individually. And this will give you better decisions, data, and numbers, and the results will be absolutely stunning. This is also the last graph. It's a comparison between what you can do with all this data when you put it in a monthly chart and compare 2 years or 3 years of the data. That is what Martin does. He took the data from his farms and make us analysis of what is going on with his data and what is the heat stress that he need to face. So that's what I have for you. The technology is called Heat Sky, and it's available worldwide in all the world. And well, I don't know if Dr. Martin will also say something about this technology.
Sure. Salvador, if you can go back 1 or 2 slides.
Yes, please. Yeah, give me a second. Okay. Okay. Give me a second. Something happened with the PowerPoint. Sorry.
I just wanted to mention that in that slide with all the different hours of the day for I think there were 15 days on that graph. There were different THI numbers being predicted for different hours during the day, and we use that information to decide when cows should be brought into the cooling area.
Which one? This one or
no,
this one?
That one here, that one there.
Okay.
So the different colors represent different severity of heat stress for each hour of the day. So if you look on the left-hand side, it's starting at 6 a.m. in the morning, and down at the bottom is 5 a.m. in the morning. So you can this gives us an indication or an idea of when the cows might be experiencing heat stress and when they need to be cooled, or when they should be concentrated on being cooled. You can see here in Mexico, I'm not exactly sure, well, it's in our region here. And we basically have 24 hours of heat stress now, with anywhere from 8 to 9 to 10 hours of severe heat stress. So this is can be a very powerful tool to help us design cooling programs.
Thank you, Marty and Salvador. That seems like a very interesting and useful program. I know that when Tom did his talk last week, my computer just went oddly. When Tom did his talk last month, it was very, very interesting, some of the data that he had. So integrating this into the program and being able to incorporate the information that you have might be really interesting. Tom's with us. Bill, you both have operated and work in areas where there is the same sort of severe heat stress that we are seeing, or that Marty and Salvador experience in Mexico. What are your thoughts?
So I think anytime that we can use data to proactively, convert it to knowledge, and so we can be more effective at, mitigating the stress before it actually does damage on the cattle, they certainly win, and we win as a result, because I think it's all part of our understanding of animal well-being. How we can create a microenvironment that basically protects them from the ambient impacts. So, appreciate the technology here. It seems very useful.
All right.
Well,
Thank you very much. I guess I'll start off our question round. I'll begin with Elena. We haven't heard from you in so long. Do you have any questions for Bill?
Yes,
Do you have any questions?
I can't resist actually. So Bill, thank you for thank you for the presentation. Very interesting, and actually it will be very useful for the next period. At least here in Italy, we are expecting hot summer as usual. And a question is related with the cooling systems. There are farmers that are building also new barns and are questioning which is the best solution. And in your opinion and experience, do you think it works better building with, soaking and ventilation, forced ventilation, compared to a completely conditioned, barn? Considering also that, water will be the next, critiques that the ambientalists, or at least, will, will point out, from agriculture.
So, Elle, when you said a completely conditioned barn, you mean enclosed?
Yes.
Yeah, I think the big determinant where we see the cross vent barns and even the tunnel barns, those serve a purpose in severe cold, I think, of providing a benefit to cattle. Any other situations, as in Italy, where you have extreme heat and humidity, I think open air is your best source of heat mitigation, moving air across wetted cows to get evaporation. And again, humidity is always going to be the factor that I think is our biggest nemesis. But certainly, I think I've seen the most success, as in those California slides, with that type of approach. And now, again, because of the humidity, evaporation is always a challenge. But soaking cows and applying the air in that fashion seems to be prudent and beneficial, as opposed to you can evaporate the moisture in the air and try to create air conditioning by cooling the local ambient environment. That tends to be a lot more energy intensive and costly than just having cycling soakers and having the fans running to move the air to evaporate.
Let me jump in there.
Go.
I've been in some of these big cross vent barns in high humidity areas in China, and they were terrible.
Yeah, that's what I thought you were going to say.
They actually went back and added, oh man, they added 30-40% more fans.
Yep.
To try and move air through the system.
Yep.
And that helped, but the cost of those fans, and then the energy cost of running all those fans,
right?
It's crazy. Soakers, and especially the new ones that Bill was showing that have the sensors that if a cow's not in front of them, they don't turn on. Getting cows wet is the only way to cool cows.
Bill and Tom and anybody in the panelists, any slide you want me to return to, just let me know and I'll find it for you.
Okay. And Tom, your observation on the cross-vent barns is, it's a year-round problem with getting adequate exchange of air throughout that entire system. And there's certainly there are times when they work much better than others, but getting the airflow patterns, and as you said, they end up just putting more and more fans into these things to try to get the dead spots that are not anticipated, that become death traps because there's just no air moving, is real. They do have an advantage in the winter in terms of thermal stress, the negative stress, but and also where there's a lot of snow and elemental challenges. But yeah, I agree wholeheartedly with you. I have been underwhelmed by a lot of the new structures that I've seen.
I really don't like cross vents, even in cold climates. I've been in some barns where they put evap coolers on sidewall fans.
Yep.
And that's fine if you're not in high humidity areas.
Right.
And
evaporation.
that's the whole issue. Yeah.
Yep. Yeah. No, I agree. And so, I concur. I don't think we've done better, especially with judicious application of water at the right cycles, allowing enough time for evaporation. I still think that's our best bet. And as a manager that has to deal with water in the lagoons, that for sure, being more discriminating about the on-off cycle, I think is important.
Okay. Thank you. Tom, do you have any comments, questions, or additions you want to provide for either presentation?
No, I'm sitting here listening, and I will
do another question then.
Oh, perfect. Thank you.
I'm sorry, one per customer. Next, please.
Okay, I will change voice. So, no, my question's still related with new building, and now they are suggesting to promote natural illumination from the roof, let's say, with the transparent, how can I say, roof, some part, and is it gonna be detrimental for heat? So we are gonna, increase the radiation. So is it better to move to artificial illumination and keep, the shade completely under the barn? What do you think?
Okay, is that for me or for Thomas? For me, right? So no question, the clear panels are going to let more radiation affect, and even opaque panels will let infrared through. So I think there's benefit to insulating under the roof to keep the solar radiation reflected back. And at the same time, I think that helps as well in the winter to maintain the right temperature within the barns, especially in extreme climates. And I think that one slide that Jeff had in there showed the clear panels and the opaque panels, but in both cases, you're getting infrared radiation coming through there to heat the cows. So I like light for cows. Cows like things illuminated so they don't have any shadows to worry about predators lurking in. But I think we can do it effectively with new LED technologies that are very, very cost effective in terms of providing illumination and not necessarily have impinging sunlight. Tom, you want to argue?
Oh, I will not argue at all. I mean, if you look at those panels, so if you go with the fiberglass ones that let less solar radiation through, they get clouded up and dirty in a matter of a year or two, and they're worthless, and they're the ones that fail first. The ones that let all the sunlight and all the radiation through are polycarb, and those things let almost all the solar radiation through, and you get severe hot spots. There's a farm near us that built a calf barn 25 years ago that used all polycarb panels for the roof and thought it was the greatest thing. And within a year or two, they ended up putting some really fancy shade cloth systems under the rafters to keep the damn thing cool. So yeah, no, bad. I agree with Bill. Layer of insulation, as Marty showed last month, he was showing some of those temperature, those from thermal cameras as to how hot the roofs get on these structures. A little bit of insulation goes a long way.
Thank you very much.
Thank you, Elena. Marty, do you have any questions or comments you would like to make?
Well, yeah, I guess I have one, and this could be directed towards Bill or Tom. Down here, last couple of years when we're soaking cows maybe 8-9 months out of the year, and some farms have experienced a skin irritation towards the end of the cooling season. I'm thinking that might be a situation where we have very hard water down here, and maybe the producers aren't getting the cows completely dry when they go back to their pen. I'm wondering if that could be a possible reason that we might be seeing some of the skin irritation. It's on the back legs and even on the udder, somewhat. And I think Salvador has seen some of this as well on some of the farms that he works with. Any comments might be are certainly welcome.
Yeah, I've seen that only in one case, Marty, specifically, and that was in Idaho, but a similar type of situation. And I took skin scrapings because it looked like a condition we see in horses called rain scald, which is basically when they get wet, but it's dirty in the hair, and you get clogged pores and follicles. And there's this bug called Dermatophilus congolensis that sets up housekeeping and lives there very successfully. And that's what it turned out to be in these cattle. And so I think it's a combination, though, of, as you said, we're not getting them dry enough, but also a dust accumulation. And I have no direct experience with what you're talking about, but if we're getting a lot of wetting and there is a lot of particulate stuff trapped in the hide, and so we're basically getting what I'm going to call a microfilm of mud close to the skin, because they're just not clean anymore, and we're not getting the benefits anymore of the soaking because we have an insulated layer now. I mean, that's a possibility, and that's just conjecture on my part. I don't know, but it would be interesting to see if, in fact, in those situations, if there is a buildup of sediment or something like that, or if it's associated with a particularly dusty point in time, those things, could attribute to it. But Tom, do you have any thoughts?
Boy, I've never heard that, but I'm sitting here thinking, what else is in the water? You say it's just really hard, Marty, but what is the mineral content of it? Is there
It can be high in calcium. It can be high in sulfates. So
what's the
we
variability
have all
on the
kinds of
pH?
things that are in the water.
Yeah. What's the variability of the pH on it? Is it, is it something as simple as that? I don't know. That would be really interesting to try and figure out. Is it on all herds or is it on specific herds?
Well, I think it varies, and it seems to having more effect or affected more first lactation animals more than the later lactation animals. One of the comments from Bill regarding dust or particulate matter, that is certainly an issue here, because we don't get a lot of rain, so there's certainly a lot of dust and particulate matter that can be airborne in these farms. So it's one of the farms that I worked with seemed to be having a problem, but then their consulting veterinarian basically said, look, the last 20 minutes of the cooling cycle, turn the water off, make sure that those cows are dry when they get back to the pen, and they had very little problems regarding this skin irritation. So that's one of their protocols right now, is to make sure that the cows are dry when they go back to the pen.
I mean, if it is, so there's several options here. It could be a chemical irritation, as Tom said, associated with pH or mineral. That makes perfect sense. It could be, the growth of a microorganism. Certainly, anytime we reduce moisture, then we reduce growth of organisms. So that has a lot of merit. If there is a buildup, at the skin level of sediment, and certainly taking a brush or curry to them just to see what comes off would be an indication of how clean the skin actually is. Now, what you could do about that, given the dusty environment, I have no idea, because it's not like we're going to shampoo the cows. But thinking out loud, if it was a regional area on the cows or just certain age groups or whatever, and I was going to do it for a limited amount of time, a diluted solution of something like a peroxide, hydrogen peroxide, which would foam and essentially create oxygenation of, close to the skin to remove scurf and debris and such, and rinsed off with the water, might be one cost-effective and simple application type of thing. Again, I'm not suggesting that this is a whole herd process. I'm just thinking out loud here as what might affect a solution if it's sediment buildup and growth of organisms. I'll let you, do the diagnosis because I'm here and you're there. But
You
but I'm
could be
glad,
there.
I'll gladly come down if you like. That's fine. we can talk later. But that would be the simplest thing, because I've used hydrogen peroxide in other situations on cattle for areas, udder rot, and things like that, where it was just impractical to have any other type of extensive treatment protocol. And this was something that was simple and easy to use and relatively cost effective. So I'm just trying to reach out for ideas here. That's all.
Sure. If I can make another comment, and it might be a surprise for Salvador. I don't know how quickly he can find maybe a photo. A couple of years ago, and I don't know if he's still doing it, Java, with your like spray-on material for on top of the roofing or the panels for cooling the barns. I don't know if you can find that photo real quick, or maybe even discuss that.
Give me a second, but let me try to find it.
While you're looking for that, I'm trying to set it up so that you can share, but I think I just need to stop share. Oh, wait here. Let me see. Yeah, it looks like you should be able to start it, Salvador, when and if you find that. So, any other questions or comments while he's looking for that? I haven't had any questions in my Q&A or my chat window, but maybe my panelists are all covering some of the questions people would ask.
Can I say something?
Yes, please.
Next month, you'll have Lance on, and I alluded to Lance as one of the researchers that's done a lot of pivotal work with his group, along with the battalion contingency, Bertoni, Traversi, Minuti. I encourage people to listen to that. I just touched upon the concept of how inflammatory response is so intimately involved in many of the issues we struggle with in cattle, especially the subclinical ones. And Lance's group has done a phenomenal job of elucidating a lot of this at the physiological level. And there's still a lot metabolically that we can't, I'll use the word justify, what the cow does and why, whether it's in terms of partitioning of nutrients like glucose or BHBs or whatever. But I really think this is the next frontier as veterinarians, as nutritionists, that we're all going to deal with as the two disciplines really become integrated together. Okay. And so nutrition and medicine.
Yes, and just to give people some heads up on what will be the coming webinars, in case you haven't looked at the roster lately. After Lance Baumgard in July, we'll have Jeff Dahl from Florida, and he's going to talk about the effects that heat stress has on more on the calf and more on her future productivity. Then in September, we're stepping away a little bit from heat stress because we're going to focus on a very large robot herd in Chile, right, Tom? Tom's not listening.
No, I was muted. Yes,
yeah.
in Chile.
Yeah, and you know a little
Los
bit.
Angeles.
Okay, and you know a little bit more about Odrim than I do. He's going to be speaking, and that will be a change for us because he's actually going to present in Spanish. And I think we're going to put Marty to hard work and have him offer the translation in English. And Paula Torillo, our our co-host in Argentina.
Uh-oh.
You turned Marianne's audio off. Yay! Salvador, you're our hero.
Fine.
That's a picture.
You can do these now, Tom, from now on. Go ahead, Salvador.
That's the special roof technology, you want to say it like that, that allow us to reduce the heat accumulation on the metal roofs in Mexico. This is a special like a pest, is a pest, and it is not heavy. In fact, it's super light, and is applied on top of the metal shades. And this decrease, you will not believe me, but if you saw in Celsius degrees, is 37.3 Celsius degree. In the bottom of the picture, you will see that the part that don't have the protection is go up to 60 degrees. It's like 20 or 25 difference of heat of difference in the Celsius temperature. It was amazing what we do with this with roof technology.
Is that metallic pigment, or is it it's like an aluminum, or what is it actually? That's going on the roof.
It's a mix of molecules of air with cellular concrete, and this is like a one centimeter of paste, and you add it on the top of the roof. It has a special additive, so you can paste it on the metal shades, and they take a strong joining with the metal, but it's not metallic paste. It's made with air, with small bubbles of air, with concrete, cellular concrete on the taking these bubbles of air. It's super light.
Does the roof have to be prepped to be cleaned in order to apply this, or can it go on any roof?
No, you're right. You need to first to clean it. These persons are applying. This one is like with a small mop or something, cleaning all the surface, and this guy is applying the molecular paste. We have equipment that is on the bottom of the shades, and there is what is all the mixture made it. And with these pumps, we put all the post on the top of the shades. It's very quickly. We do like one of these measure in Mexico is 200 line of meters of length.
Yeah.
And we did it 2 of those in one day. It's quickly to apply. It's very quickly. And it helps a lot. The other thing that we're doing this year is putting that technology into the calves shades. As you know, here in Mexico, we use this is wood with
wooden calf hutches.
Yeah,
okay.
Yes, the hutches. And we're trying to reduce the heat stress from the calves with this technology on the shades, of the metal shades for the hutches.
You're making this, Salvador? This is your company?
Yes, we're partnered with another company that we are doing this in Mexico. We provide solutions for heat stress. We sell fans, we sell the pipes of sprinklers. We use the controls, provide the data for this, and also we're trying to develop additional technologies that helps to reduce the heat stress. We're working with Dr. Traxler for a few years ago, and we're trying to innovate technologies in different ways.
I'm just curious if these panels that are coated went through freezing and thawing cycles. In other words, in areas where it gets below 0 centigrade, would the adhesion still be there, or is it's not made for that climate? It's just made for where you're continuously warm. You understand my question?
Yes, I get it, but I'm not sure if it is decided for cooling, for cool environments. For heat environments, it works well. Let me see if I can do a trials with put it in a fridge or something. See if I can below 20 degrees below 0 in here, and what it happens, because here in Mexico we don't have those scenarios
Right.
of those, but it's a great question. I don't know what is going to happen with the
Well,
bubbles
because we are using foams under the tin, as they say, in a lot of our barns to insulate them after the fact of being built, and it's very expensive. What I'm just wondering here is this surface application, besides being insulating, assuming that it adheres in our extremes of temperature, it might also prolong the life of the roof, you know, against precipitation in the elements. But again, I'm just thinking out loud here. So what, Tom, your thoughts?
Oh, I'm sitting here just drooling and thinking of all the applications, and even wondering, well, maybe in a freeze thaw cycle, maybe we would need to put a fiberglass mesh or a nylon mesh in it.
Yeah,
that would just
you're
give
going
it,
where you're
yeah,
going the same place I'm going. Yeah,
yeah,
exactly.
give it some more structural integrity.
Yeah, because what I'm worried about is expansion, contraction, and having it fracture, you know, or develop cracks that would then trap moisture, right? And then,
Right.
you know, all of that, and then it freezes, and then it lifts, you know. So, but
Well,
again,
there's options, but
yeah,
damn, I'm sitting here thinking, okay, Salvador, we need to like start some affiliate companies, and I'm looking at thinking about this, all the places in the world that are like, holy crap, this would be flipping awesome.
Yeah, perfect. I am going to help. In fact, if you saw, when you applied it, it take a white color. For example, here is gray color because it has some humidity. But in the moment that it dries and fixed to the shade, it changes to a white color. So it also don't allow to accumulate.
Reflects the light.
Yeah, we get a lot of reflection. Yeah.
Yeah.
How long does it take to dry once you apply it?
15 to 20 minutes.
At your temperatures, right? So that, again, I'm just thinking of other
It's not really a
situations.
drying. It's not really a drying. It's a curing.
Right. Yeah. But
So
to become stable is what I meant, you know, to resolve, to cure.
It's gonna be pretty damn quick mixed with air.
Yeah. Well, yeah, but humidity might have a factor in that, Tom.
Small.
You don't think?
Nope. You look at concrete curing, and actually the humidity, a little bit of humidity would actually make it cure better.
Does this give off heat when it cures? Does it?
Yeah, they're exothermic. Yeah.
Yeah. Well, concrete is, yes. I
Yeah.
didn't know if this would be.
Well, it depends. Yeah. It depends on the ingredients in it. So,
right.
And I don't expect Salvador to disclose actually what's
No.
that's
I'm just thinking the limitations of application. You know, they're in the ideal world to apply something like this. Okay, I'm thinking about other areas where we might want to use it, but the window of application may be, you know, constrained by just the environmental influences. That's all. But certainly worth looking at.
Yeah. Very cool.
Thank you.
Yeah.
Thanks,
Look forward to
Salvador.
hearing more.
So
Yep.
I'm going to change my share and then ask you if you would give us a little talk on your product. So let's go there. I think I need to get to the beginning. All right, I think we're ready.
Okay, thank you very much. I am Salvador Rivas. I am founder and CEO of DigiSky Technologies in Mexico. And I am working very close with Lattice team, with Dr. Martin Traxler and all the what they are doing here in Mexico. First slide, please. Go to the first one. First of all, I would like to talk about the THI or heat stress. I know that everyone here in the room knows what it is. We have this scale, well, this chart in the left side, where we can find the Fahrenheit or Celsius row, and here are the columns with the humidity, and then when you match the temperature and the humidity, it's going to be an ETH index. This index is divided in five zones, if you want to say it that way. That is no stress, light stress, moderate stress, high stress, and dangerous stress. It started at 68 THI, so it's more the same. If we have here 81 Fahrenheit at 0 humidity, that if we have 75 Fahrenheit, but with 50% of humidity. And what it happens is that when you rise from the known stress to the light stress or the moderate stress, the cow starts to accumulate the heat stress. We developed this application that you're seeing here in the right side of the presentation, and the name is Digit, the Digit tool. We developed this technology a few years ago. The idea was that that you could have enough data to do the right decisions to face the heat stress. Let me try to put an example. I love cars, and I always compare heat stress with the F1 Formula cars. Let's face that the heat stress is the Ferrari team, and they are running fearlessly, okay? And you want to try to face them, but you are blind on your eyes. So how you are going to win the race if you are not available to see your enemy? So with this technology, what you will have is 7 days in advance with an 98% forecast technology, with an 80% of accuracy, with 7 days of THI in any place of the world. So it works with a satellite network that gives you the accurate data for each location in all the world that you will find the heat stress. And with this data, you can take the right decisions to abate that heat stress. If we can go to the next slide, please. This is the data that we are getting from the system. We can have the temperature in Celsius or Fahrenheit, the ambient humidity, and of course the THI. If you see here in this chart, you will see that the bottom is no stress. Here is the line of 68, 69. Then goes the light stress up to 74 THI. Then comes the middle stress up to 80s, the dangerous of 87, and then the dangerous up to 100. And what the technology does is to put the heat stress in a 24 hours line, so you can make what is going on with the heat stress in the follow hours or on the follow days, hour per hour, that you can take this data, and you can also has the wind direction, the wind dusts, even how many lights, the daylight that you will have in the day, the sunrise, sunsets. And this heat stress analysis gives you the opportunity to face a complete week and understand what is going on with the heat stress on this week. And if we can see the next chart, the next slide, please. Okay, this is commonly how the system gives you the data. You will see here that this is a 15 days 15 days data. You are on the middle. For example, this data was taken just the 30th of May, well, 2 days ago, 30th of May. And we have 7 days previously, and we have the next follow 7 days that we will face in the follow days. And what can we saw is that we will have 24 hours of heat stress here in Mexico, in the Laguna, Torreón, Legión Lagunera. And the middle stress will start between 10 a.m. to 11 a.m. and it will finish between 9 or 10 p.m. So this is your critical area that you need to be sure that you will provide the enough cooling and the proper management in your farms. And in this place that is light stress, okay, it will have a light stress, but the cow can face the light stress with water or with wine or something. This is what we try to get. Please, the next slide. With all this data, what we do is, this is an example of the report that you got. This technology that we are speaking about is a system, is a technology that gives you the data. So if any of you want to see what is the weather or the forecast seen in a THI or heat stress point of view, you can only send us the GPS position of your farm, and automatically we will start making all the data from that GPS point. And you will have this data every day or every week as you prefer. You will have temperature, humidity, THI, the average of clouds that you will have on those days, the UV index, and also a graph of all this data, put it in a graph system. The important thing of all this is what you do with all this data. And if we can see the next slide, this is what we're doing with this is example of how the graphical data came from all the report. And you can see here easily, the same bands that we discussed a little bit before, that there is no stress, light stress, heat is moderate, high, or dangerous stress. These are the 24 hours of the THI. The red line is the temperature, and this is the humidity that you will face during the day. So we can see that, for example, here in Torreón, we have humidity on the afternoon, on the morning, sorry. And in the afternoon, that it drops dramatically the humidity, but it increases or rises on temperature. And this combination gives you heat stress levels up to the moderate and go to the high level heat stress. And also the wind, we can see here that the wind is coming from the northeast in this particular place. So with this, we can also make adjustments or know only where is the wind coming. Here we have what is the sunset, the sunrise, how many hours do we have from daylight, and how was the THI average and the maximum, the minimum humidity and temperature of the day. That's how the heat sky technology works. And with all this data, if we can go to the next slide, what we can do is this. This is a map of 1 year of heat stress here in Torreón from February to November of 2022. And we have here the 24 hours of the day, and we have here what's going on daily on a basis of THI. So the white bands are there's no stress. Yellow ones are light stress. The orange are moderate stress, and red ones were the high level of heat stress. And we can see here that in Mexico, in this region particularly, about the middle of April to middle of September, we will face more than 24 or 20 hours of heat stress. And between May and August, we will have the peaks of the heat stress. At least this is what is going on that year, the previous year. And with this, we have all this data, statistical data that can help you to your nutritionist or all the team that you have in the farm, so you can take decisions about how to calibrate your diet or something like that. Please go to the next one, please. And also we have the ability to compare 2 years or 3 years if you wanted to. So I think it's a powerful tool. So if you have the data, you can take the right decisions and make the proper statistics. And in the final slide, I think, well, we were discussing a little bit about this technology also. It's a thermal insulation foam that go up the metal shades that you have in the farm. These go perfectly takes to the metal shades and provides perfect thermal insulation, as you can see here, before the installation or the place that is no the installation. We have 72.4 Celsius degrees in a usual August summer here in Mexico. But look what happened when you add the thermal solution. It goes to the normal temperature that we have here, that is 37 to 40 degrees in the summer. So I think it's a powerful tool. We were talking about this and how this can help you also to reduce the heat stress inside the barns, in the farms, or even on the hatches with the cattle. And I think this is the last slide that we have here. And yes, well, it was a pleasure to me to show you this. I am Salvatore Rivas. I am working with Dr. Martin in Mexico with the LaTeX team. And please feel free to ask anything if you have any questions. Thank you.
Thank you. I'm going to switch back to our other presentation, and I can switch between the two of these if we have any specific questions on either presentation. Bill, as you're explaining things or anybody making comments, just let me know what slide to go to and I can do that. So thank you so much, and let's get started. I have a couple questions and comments, and I know that Paula does as well. Paula said that, and I'm hoping Paula will join in with me on this first question. This is somewhat of a comment or more of a discussion point. On drinking water temperatures, cows prefer and will drink more ambient water over cool water. Cool water changes the internal temperature of the rumen, slowing fermentation. Paula, you said you had a similar question. Do you want to add on yours, and then we'll have Bill and anybody else on the panel that would like to discuss this point? Go at it.
Is there another comment coming or not?
I'm not sure. Paula sometimes has struggles with microphones. So I'm going to give her a second and go ahead. She'll catch up if she's able to speak, but right now I'm not seeing her unmute go off. So
Yeah, so the cattle in general do not like cold water, and the shock to the rumen, I think, is dissipated by core temperature pretty quickly. I don't think it's disruptive for that long, but they will drink tepid water preferentially, from the few studies that I've ever seen out there, over cold or warmer. So, and anything that's below their core temperature is going to serve as a cooling phenomenon, because there's going to be conduction away from the higher temperature to the lower temperature. So there's going to be a cooling effect, even if it is not truly cold water, as we people tend to enjoy under conditions of heat stress. So yeah,
I'm not advocating we refrigerate the water, that the water is cold. Now, the bigger issue may be the water coming out of the system is already warm naturally, and they're still going to drink, obviously, because they need the water. Okay. We'll drink warm water if that's what we have rather than die of thirst. So, yeah, it's one of those things. It depends on the situation, but tepid seems to be the preference of livestock, okay, which is we'll call it a thermoneutral temperature.
So, are there some systems that actually use the drinking water for the cows to do some pre-cooling of the milk? Is that a potential issue, or am I catching that wrong?
No, that could be done, especially in colder climates where they want to bring the water temperature up to be more tepid in the winter months. I don't know, and I'll stand corrected of any that are doing it, routinely in the warm months or using that water alone. Because again, if we make the temperature too warm, their preference for it is not going to be that great. We want them to drink water because that drives dry matter intake, obviously. So, yeah, there's no countercurrent heat exchange is done, in all aspects on dairies to scavenge waste heat, and certainly, with water potential for freezing in some situations in northern climates, that's one way to mitigate the risk of having frozen waters.
Okay. Thank
Tom,
you.
I was gonna,
Tom,
I'm
you
sorry,
have any?
Marianne, I was gonna make a comment.
Yes, please.
There are, I believe, a couple of companies that produce a wireless bolus that you can put into the rumen of cattle that are used basically to measure the temperature, internal temperature of the cow by using the rumen temperature as a proxy. But they will definitely let you know when the cattle drinks water, because the temperature of the rumen will drop a little bit for a short period of time.
Yep, exactly.
Okay, thank you. And there's a comment from Dr. Jones, Gordy Jones is in our group, that said many farms do use plate cooler water for drinking water year round. So Paula informs me that her microphone is not working.
Oh.
Unfortunately, because she always has such great questions. I am going to ask questions for her. So while she's busy compiling them, I'll start with one. Is
I'm
there
glad. I'm glad her microphone is not working, because she would harass me about wanting to talk about September.
So yeah, and you deserve all the harassment you get, might I add. And Paula can type it in and I'll harass you for her. Anyway, is there a practical scoring system to assess how soaked the cows are in the herd? Anybody?
I think it's highly subjective. And again, I think it's recognizing, as showed in the photos, when you see the backs of them shiny like that, that there's obviously reflecting, because the water is saturated. But I don't know of any objective way of measuring that, but maybe someone knows of one. Tom, do you have anything in your toolkit that suggests that? Or, and if you're,
I've never heard of such a thing, and I guess my reaction to that would be, forget scoring systems. Just go look at the cows, take pictures of the cows. If they look wet, they're wet. If they're not, then they're not wet enough.
That seems like a good scoring system. Can you explain more the change in the physiology through the use of RFC?
so what we understand about the mechanism of action is it reduces the challenge at the enterocyte level. So you're effectively reducing the incidence of inflammation. There's work done that shows it works against mycotoxins, and so there's less cytotoxic damage to the lining of the gut. And we're not talking rumen here; we're talking intestinal tract. And although there is a rumen advantage as well, but and so it basically is reducing the challenge, fortifying, improving resistance against certain challenges, and thereby reducing the chance of exaggerated inflammatory responses that are very energy costly, okay, as it showed from Kivadera's study there with the euglycemic clamp. And so that is, and there are some effects that we don't fully understand why it has a negative effect on crypto and a negative effect on coxy. But there's certainly benefits to pulling the moiety apart, the yeast cell, into the active ingredients, which independently have been demonstrated in vitro to have a benefit, and in vivo. So yeah, it's not necessarily complete science, but it improves resiliency of the cow to the challenge of the environment. That's kind of. Go ahead.
Sorry, as a follow-up from Paula, why don't they pant more? And also, they don't hear Tom is not, they don't hear him properly, which is fine.
Yeah, so the panting side of that, okay, comes from the fact that the heat stress that requires them to do more evaporative exchange, and all the other cows are still breathing, but they haven't gotten to the inflamed state that the other cows have, okay, which results in temperature increases, things like that, because there's not the inflammatory response taking place that's going to exacerbate the need to cool themselves, okay, whereas these other cows, I'm sure there's some inflammation, but certainly it would be the difference between clinical and subclinical, okay, they've got it more under control. So that would be my impression.
Okay, thank you. I am waiting. The product, can it be used on calves? And this is from Paula, and she's thinking of cryptosporidium.
Yes, it is used on calves very much for that reason. There's a form that's liquid form that goes readily into milk, or a soluble powder that's used. And again, I'm not telling you to use it. I will tell you that I have used it successfully on the dairies that I've managed, and I'm very pleased with it. So it offers great benefit, not just for that, but also for help mitigate some of the pathogens, because it'll bind E. coli and salmonella and all the other Enterobacteriaceae with pili on them that are the known potential pathogens. So is it a magic bullet? No, it just helps reduce the challenges, okay, for the full length of the gut. And the science makes a lot of sense.
Is it approved in Argentina?
Good question. I believe
Argentina, Chile,
Uruguay. Yeah, I know that there was work being done a while ago to get the approval process on that stuff.
Is this Seminex?
Yeah.
Okay. That Paula's asking. She doesn't know.
Yeah, I don't know either, but I know it's in process if it's not. And there's probably no reason why it wouldn't be approved.
And are some of these ingredients naturally available or occurring in feeds? In some feeds?
Well, it's a yeast cell wall derivative. So to the extent that there might be yeast there, I mean, basically you're taking in a yeast cell and fractionating it with enzymes into its active ingredients, or what we call its active ingredients for protecting the gastrointestinal tract. So the problem with intact yeast is that you don't necessarily get the activity of the specific moieties, because the yeast cell tends to stay intact for the most part, unless you do something to cause it to dissociate. And this is done enzymatically in this particular product to increase the potency, if you will, of the activity.
Okay. All right. I Is there any panelist type discussion that you want to have happen? There are no more questions in Argentina, and I have no more questions here. Does anybody have any comments or thoughts they want to share before we end this?
Let me say something. This is, folks, this is not just an issue about cooling the lactating cows. Do the dry cows, consider the close-up cows. They are equally, if not more important than the lactating cows. Now you can go, Marty.
Okay, I agree with that statement. And there's probably something coming up later on in the year to talk about that from the Florida group.
Yes, Jeff is speaking in August.
I was going to mention, and I think actually both Bill and Salvador mentioned it, but I kind of want to tie it up. The information that Salvador is presenting or can provide us, and myself and some of the farms that I work with use that hourly prediction of heat stress to actually program their cooling systems. Bill talked about as the temperature goes up or as the THI goes up, you need to change the time of water application versus the fan in those 5-minute cycles. So when you have this prediction of THI for each hour of the day, that's very useful for programming the cooling systems in such a way that the manager of the farm wishes, rather than letting that be dependent upon by a person that's bringing cows in from the pen and putting them into the cooling stall.
And good point, Marty. And because that helps remove some of the subjectivity once we get the system automated and we're at the right interval. But Marianne, if you go back, I don't know how many slides, but to Tom's point, and I'll bring this up again, the work that Trevisi, Minuti, Bertoni did in Italy. Keep going. There. Oh, no. 60, slide 60.
Okay.
60. You're going the wrong way.
No, I'm not.
Well, it is
I
on
think
mine.
there's a lag. 60 on yours, 60 on mine, or 60 on yours?
There we go. That's it. So
Yeah.
this graph that shows these spikes in the inflammatory response were dry cows. Okay. This is transition cows that showed no clinical signs, but this shows that they're going through, and I'm not saying it was heat stress. It could have been any number of environment. It could have been overcrowding. It could have been any number of things. But the point is, this is not just for the lactating cow, which we focus on because she's the only one that's producing anything, right? This is happening to the entire herd. And what you will hear from Lance, I'll give you a preview as to why you want to dial in. Fresh cows, the problems that we see in fresh cows are probably typically assigned to a hypocalcemic situation. And there's no statistical cause and effect ever demonstrated about that. Why hypocalcemia as a gateway disease, certainly it can be associated with things, but what's more compelling is the fact that when they start looking at true fresh cow diseases, the cows that undergo metabolic challenges in the fresh window have had an inflammatory response days, if not weeks prior to that lead up to this fresh cow crisis. So the true cause of a lot of these, the root cause, is starting in the transition, and it can be tracked by looking at markers of inflammation, which we can't do practically in the field, but we can at least understand why we should do everything we can to mitigate the inflammatory response. So, and Lance has got tremendous information on this, so you got to be here for the next one. It's awesome.
And I'm just going to say that any woman who's ever been pregnant in the summer is not surprised by any of this. Just saying.
Okay.
You guys can't relate. But.
No.
All right.
Yes, we can, because we've lived with it.
I
Oh,
knew that was coming. I knew that was coming.
Things. Paula
I-
agrees with me, and I feel so much sympathy for you guys having to live with us. Yeah, go ahead. Sorry, again, it's digressing. Thank you, everybody. I think we are, yes, encourage you. This is for Argentina, we're going into winter, but we're all thinking summer as it's it's only 80 degrees out according to my watch. But it's been a very hot day here and very dry. So it looks like it's going to be a scorcher this summer. Thanks for joining us. We will have this process and up. Thank you, Salvador and Marty and Tom and Paula, and especially you, Bill. Great presentation. Gordy Jones says, good job. So unless somebody's got something else to say, I'll see you all next month.
Marianne, I think
Yes.
I was visiting with Salvador. He might have a couple of 1 or 2 slides that he measuring the temperature of the cow during the day. We can identify if the people cooling the cows are doing a good job or a bad job. And that might be interesting to see.
Yeah. But this drives Paula nuts. Yes, we can do that. Can you very quickly send them to me and I can send them to Paula so she can share, or is this just gonna make it all crash down?
Give me 10 seconds. I'm going to send her 2 slides quickly.
Okay. I am going to let's see. I'm going to stop my share if I can find my Zoom. There we go. Stop share. Paula, so sorry. She stopped her meeting. She just gave up. So she's still here though. And this will be recorded, Paula, for you to process later. Bill, you can talk.
Oh, I didn't want to step on anybody. That's all.
Oh no, we need you to fill dead space while Salvador.
What, the awkward silence?
Yeah. Gordy can't talk back to you, but you can talk to him.
Why can't he talk back?
I don't let him.
I
suppose I could if y'all want that to happen.
If he would like to, that's fine with me.
All right.
I've
Gordy, would
I've
you like to
enjoyed his
talk?
company for 20 some years, and so I'm not about to curtail it now. So
All right. I'm letting him talk. He just has to unmute himself.
that's fine.
Hey, good afternoon. Nice job.
Hey, how are you, my man?
I'm good.
Good.
I'm good. I live in Florida now. You may have heard.
Oh yeah, no, I saw you that time in Indy when for
when Carly passed.
Yeah, right. Exactly. Yeah. So
Yeah.
no.
Can you please see if the email arrives?
Yes, it did. I just need to open them. Which one would you like first?
There are 2 PDFs. Please start with anyone. Choose anyone you want.
Okay. Let me reshare. I am just going to share a screen so that I can move them in and out. There we go.
Okay. Can please we go zoom into the middle chart, please?
Just enlarge it.
Yeah, I'm not as adept with, there we go.
Here we go. Perfect. Okay, so this is an example of one cow that we are cooling, okay? Dr. Martin, if you can say something, please feel free to. I am only show you two reports. The first one is these blue lines that we can see in the report. What it tells you is the moment of time that the cow that we took this cow to the cooling area. We have cooling areas here in some farms in Turan. So they have these 30 minutes or 40 minutes of cooling. And then there are the second one here is when it comes to the milking area. And also we have the sprinklers with fans. We have the box with the fans and the sprinklers. And then after a few hours, what we can see is that between 8 a.m. to 9 a.m., the heat stress starts rising. This is the body temperature of the cow that is measurement with a vaginal instrument that is measuring every five minutes the temperature inside the cow. So with this, we are taking decisions if we are cooling the cows in the proper way or if we need to add or reduce the amount of cooling that we are providing to the cow. So, for example, this is the goal that we want to be always between 38 degrees to 39 degrees. That is more like, I think it's below 100 Fahrenheit. And this is 39.5, the limit that we're accepting as a maximum temperature of the body internal in the animals. And what we can see here in the afternoons, that what is happening is that the cow with the cooling providing that we are doing, they are getting the proper temperature in the middle day. And in the night, what we can see is also it drops. But let's see what happened in the other graph. Can you please open the second report, please? What we can see here, if you saw the pink graphs that is outside, that means that some of the day something was not properly provided, and what we can see is that this day the cow rises up to 40, is 103 Fahrenheit. So the cow accumulates temperature on in this particular period of time between 2 p.m. to 5 p.m. And also when it goes back to the milking parlor, we can see that the cow did not drops in temperature. The red line is the average body inside the internal temperature of the cow. But the pink graph is the maximum and minimum temperature that these cows have on this week that we are measuring. So what this is telling us is that some of the days of this week, maybe you don't cool your cows properly in the afternoon, but in the morning they are doing a very good job. So with this, we mix also the data from other technologies like rumination time, the lying time down, the protein, the fat of the cows, and trying to understand what is going on with the cows through the heat stress. Martin and me are seeing these reports. I don't know how many years now, Martin, but I think like 10 or 8, maybe 8 or 7 years now, seeing these kind of graphs on a lot of farms here in Mexico, and we measure this weekly in all the farms. I don't know if you want to add something.
On this particular graph, that kind of a shaded area behind the dark red line, Salvador mentioned that was the range in daily temperatures over a period of 1 week. In the case of this cow, I see that she has 219 days in milk. I don't know how many days she would be pregnant, but that may be that temperature that's getting up to 40 degrees may be detrimental to the survivability of a fetus or a young a fetus in early gestation, which might be responsible for poor reproduction in the summertime. So it becomes important to kind of pay attention to this and make sure that we are able to keep these cows cow temperature below that dotted line of 39.5.
So Marty, what's the intervention at that point? Are you increasing the interval of soaking or, you know, I mean, what do you do? Are you taking them, are you driving them to a cooler area so they have a chance to cool off, like a pool cell area or something? Or I'm just curious, you know, what's the intervention?
Actually, yeah, Bill, I'm not quite familiar with this particular farm, but it could be nothing more than a situation of the evening crew or the night crew is not getting these cows into the cooling area like they should be.
Okay.
For 1 or 2 days, like this is the range. So it may be simply only 1 day in which the cow maybe was laying down in the pen and the person that was in charge of cooling did not get her up and bring her into the cooling area. So that needs to be investigated.
And the cooling area is Saudi coolers, or is it just soaking in fans?
It'd be soaking in fans. So there will be a facility that might have tunnels like some of the Israeli people are talking about.
Yep.
In which you bring the cows in and you spray them and force air on them, and then for 35 to 40 minutes, whatever it happens to be. And if you can determine, in this case, the problem is it's at night, so you might not be able to identify what's going on unless you have cameras set up in the cooling area to see if the cows in fact are being brought to the cooling area.
Okay, got it.
And
Right.
Okay,
that's correct, Salvador, right?
Excuse me?
That's correct, what I was stating, wasn't it?
Yes, perfectly correct, Marcy. Yes. And if you please let me just show you a last graph. I sent a last email to Marianne. I don't know if it arrives.
I just put it up.
This is a different kind of cooling, for example, and this farm uses the technology of cooling inside the barns. So we don't took the cows to the cooling areas. The cooling is inside the barns. And this, if you saw the date is 15th of May to 22nd of May 23. It happened only the last week. And what we can see here is that they are cooling perfectly well. The cows, they are between the 38 to 39 degrees. And they are really doing a good job with the cooling edge. So we're working with different models of cooling in Mexico. Those ones that have the ability to put cooling inside the barns can measure in this way, or if they have cooling areas specific for cool your cows because you don't have the slopes or something to direct the water or something. Well, we have different solutions to all the farms here in Mexico to give cooling technologies and cooling solutions for the dairies. I like what I am seeing right now in this particular farm with the cooling inside the barns, because you don't take the cows to another place and they are getting a great cooling and behavior inside those barns, as you can see it in the graph. This is Beta, Martin, that you know perfectly well, the Beta Santa Monica. And it's amazing what we're seeing here.
Okay. That's terrific. Thank you for sharing these with us. Let me see if I have any questions. One of the things I could offer to do is just be able to show them side by side if you wanted me to. So you can see the difference, but anyway, thank you. Any questions? If not, we'll draw this to an end. Paula, I'm so sorry that it's not working. We have to figure something out. But it's good to have you here in spirit. And Bill, Terrific to have you talk. Paula
Nada.
says thank you.
Nada.
And everybody, thank you for coming. And we'll see you next month. I am delighted to co-host this series with Dr. Paula Turillo from Afina in Argentina and Dr. Bill Prokop from Dairy Innovations. We also share hosting honors with several of our AMTS distributors. Dr. Marty Traxler of La Tech, distributor in Mexico, Dr. Elena Bonfante of Dairy Innovations Italia, our Italian distributor, Dr. Sean Lee of Ansci Tech, AMTS distributor in China, and Dr. Marcelo Hens Ramos of 3R Lab and AMTS distributor in Brazil. I am also joined by my colleagues Lynn Gilbert and Tom Toluki of AMTS. We wish to thank our wonderful sponsors who allow us to pay our speakers and help justify our time commitment to this project. We thank our gold sponsors, Arm & Hammer Animal and Food Production, #ScienceHearted, the Canola Council of Canada. Discover the amazing value of canola meal at canolamazing.com. Adina, experts in animal nutrition with expertise in plant bioactives, and Protetka, transforming the future of farm animal health. Our silver sponsors this year are the Forage Analysis Labs of Dairyland Laboratory with affiliates around the world, and Adiseo Ruminant Nutrition Solutions to ensure animal performance. Our bronze sponsors are AminoMax, Virtus Nutrition, Balchem, the Milk Group, and Barron's. Each of these companies support education and research worldwide. We hope you consider them in your formulation decisions. Thank you so much for joining us to listen to this recorded webinar, and we hope to see you in our next webinar.